Okay, today I'm going to do circle packing to start with. No, it's a light start. Then circle packing does something like this. So you create random spheres around the space. And these random spheres have different radiuses and different positions, and they try to repel from each other. So their basic principle in their calculation is similar to the agent script. So basically, they are only calculating their neighbor, and if you are closer than your radius, you push away. If you are not, then you stay. So once you do them multiple times, it creates this effect, and you can actually replace this geometry with other geometries in the later script. Okay, all right. Okay, let's right click, create a empty game object. Let's call this one circle packing. Make sure that you reset the 000. Okay. Right click, create a folder called scripts. And then right click, create a folder called prefabs. And then right click, let's create a empty object called main agent geometry, agent geo. And then let's put a right click, put a sphere that is 0, reset, and then put this under the agent geo and drag that inside this prefab folder. It's a basic setup. Okay, and then you can delete this. Sphere, one sphere. One sphere with the dimension of 1. This is dimension. The size is dimension. It's not radius. But that's fine. Okay, and then you can, once this became blue, you can delete it. Delete from scene. Okay, make sure your scene is saved. So hit Control S. Okay, in the circle packing, this is empty script. Let me show you a way to create another way of creating C#. So say add component, and then let's say circle packing. And then there is nothing as such, and it's suggesting you to create a C# file. So say create, and it's automatically creating a C# file that's called circle packing. And now you can drag this inside the scripts folder. Alternatively, you can do it like yesterday, right? So you go to this folder, right click, and create a C# script any way you want. Okay, and then we can go to this circle packing and right click and say edit script. That's how you can edit, or you can double click in the assets folder. All right, now we have a good circle packing main menu. We have mono behavior as a main circle packing. We are going to make 2 more scripts, 2 more like voids. We are going to make we made a void system and void agent, right? We are going to make a circle system and circle agent. So right click, create C# script called circle system. Right click, create a C# script called circle agent. Circle agent. All right. Now double click on both of them. Okay, I have circle packing, circle system. Did I close the packing? Okay, so we have circle packing. Where is the system? Circle packing. Where is the circle system? The circle system. Double click. Okay, maybe I didn't click. Okay, so you have circle packing, you have circle system, circle agent. Okay, that's good. So first thing first, what do you think a circle will need as a property? Radius and location, yes. Okay, so we are going to, so first thing first, this is not going to be my interface to Unity, so we delete everything and the mono behavior. Let's do that for the system also. So go to the system and clean it up. Delete and delete the mono behavior. Save. All good, clean, very clean. Okay, and then we are going to create a constructor, public circle agent, and we will need two information. So we will need a public vector3 called, I'm gonna call it center capital, and then I'm going to give a initial 0 just for a default. You don't have to do it actually, but just to prevent any error. And then here we are going to bring a vector3 at called center with lowercase and pass it to the global behavior, global variable. Is this clear? Okay, let's do that for the radius as well. Public float radius. I give a initial 0 just to prevent any error. Let's give 1 radius. And then float radius lowercase and pass it to the global variable radius. This is good. Now a circle agent has two information. One is center and one is radius. Okay, so let's call this, let's create this in circle system. So in circle system, when we just newly create, let's have information of the number of circle. So go ahead and do it. Create a constructor of circle system with the information of a count. Try it. Okay, I'm gonna write it public circle system. And then it's going to have an input of integer agent count. You just make sure count. And so use a lowercase agent count. This is not going to have, doesn't have to be declared because inside here, we are going to create that amount of agents. So for loop, for int I is 0, I is smaller than a agent count, I plus plus. We are going to create one circle agent in each loop. So how do we create a circle agent? So circle agent, I'm going to call it CA, circle agent. And then this will need a circle agent, will need a information of a center and a radius, correct? So we are going to use declare a vector 3, a new center is a new set vector 3, and I am going to give it a little bit of range because it's creating random. So we are going to create random. Do you remember yesterday we were saying random is a unity engine dot random? We are going to use unity random, say random dot range. We are going to use a minimum and maximum number to define what are the area radius of this thing. So we are going to say minus, let's say minus 10 to 10. Minus 10 to 10. This is going to be long. And actually this range, if I want to change it, I need to change it 6 times, right? That's really inconvenient. So I'm going to say a range of area, which is for now, I'm going to set it as 10. And then this will go from minus 10 to 10. So it's the same effect, but I don't have to change every time when I want to change the radius. Okay. And in the future, we are going to make this into a global variable where we can access from outside. Okay, so that is the center. We got the first one. And then we are going to make the second radius is random range dot range. And here I'm also going to declare a range, plot range of radius. And then I'm going to give around 5 for now. And then this random range, because this radius shouldn't be smaller than 0, because it's a size. So we are going to make it around 0.5f to range radius. So the reason I'm doing this too, like this, is that I can change this outside in the future. So now we have created the system. And then let's make a list. So we can store all of these CA, circle agents. Okay. So let's make a public list of circle agents. All agents. And whenever we are creating a new circle system, we are creating an empty circle system list, circle agent, list of circle agents. And then whenever we create one CA, we add to this list. Now, finally, we constructed the circle system. Okay. Let's go out to circle packing and let's construct this system. All right, so in the start, we are going to create one circle system. We are going to call it C system. And whenever I start the frame, I will create a new circle system. And what do we need for creating a circle system? What do we need? Number of it, right? We need the count of it. So if we want to make 100 of them, we say 100. All right. And in the updates, so we don't have anything to update, to be honest. Now we don't have any movements, but there's no display, right? It only, but in the update, let me do something like this. So print, I'm going to debug and test if I have successfully created the circle system and agents. So I'm going to print the number of a C system. You remember this is to convert a number into string, correct? And then I'm going to use C systems all agents count to see if I have successfully created 100 of agents. So let's see. So I'm going to, I saved all these 3 tabs and now I play it. I should see 100 is printing in the console without any error. Okay, that's great. Everybody got there? I'm going to pause this, but we can always come back and debug this. So this is basic structure. This all clear, right? Okay, so let's make this into a display. All right. So what we are going to do is we are going to set up, we are going to bring a prefab as a game object. And then in the start, we instantiate them. And in update, we are going to change their positions according to newly updated circle packing center points. Got it? Okay. So in the global variable, we are going to bring a prefab. So game object, agent prefab, Control S. Now in the script, in the Unity, circle packing will ask you to give you a agent prefab. So we are going to give that prefab we just created, this one, to this thing. Then we are ready. All right. So in the start, we are going to set up, and just to be more clean in terms of the script, we are going to make a method instead of like adding the dirty lines inside the script. So what we are going to do, we are going to make a method called setupGeo. This is exactly the same as what we coded for the boys yesterday. We are going to use for each circle C system, C system for each, circle agent CA in C system dot O agents. So basically we are looping through all the agents one by one, and their type is circle agent. And then we are going to let these agents to instantiate, let a new geometry to be instantiated on the CA center point. So instantiate the geometry that we just get, agent prefab, Control C, Control V. And then we are going to use CA center, and the rotation, we are going to make a quaternion in a bit. So let's create a rotation vector that is a quaternion. So quaternion rotation is a quaternion with loop rotation, and we are going to use a up arrow because the rotation doesn't really matter because it's a sphere. So now we have the quaternion. We just simply add that, and then Control C and paste, pull this in the setup, in the start. Okay, now we are ready to run this. We should be able to see a random 100 of circles. Do you have it? So yes, I'm gonna move the game scene here so I can see the scene. All right. If you all get this, that's great. Okay, let's go back to the circle agent. Let's give a simple movement. So let's make a public void update. And here we are going to simply let this center to increase every time. So center plus is a small vector. Let's say a new random vector, 0.1f, 0, 0. So every time when this is updated, it should move towards the x direction, correct? Okay. So we are going to go to the system to call this. So go to the circle system. And inside here, we are going to call a public update function. And we are going to go through each of these agents and call update. So what we do is for each CA, so agent, so circle agent, CA, in O agents, we are going to let CA to update. Control S. And this is still not called because we didn't call it in the circle packing. So go back to the circle packing script. And in the update, you want to update C system. C system dot update. You can run this now. It shouldn't error, but it's still not updating anything because we didn't update the geometry. We updated the agent, but we didn't update the geometry, correct? So let's just run it so we know that there is no error. We should still see the initial point. That's great. Okay, so let's make an update geometry. So void update geometry. And for each, I'm gonna copy this. Control C, Control V, parenthesis. And then say all agent prefab. So we need to access this as a list when it's created because we wanna update their own geometries, right? So we are going to create a global list called list of game objects, all agent prefabs, okay, and then Control C. When you set up the geometry here, you need to create a new list, game objects. List of game objects, new. And whenever you create a new geometry, let's declare this game object new geo. You add this to this list. So we can access this from this update geo. So now as we have this list, we actually need to get both geometries. So it's actually better to use for int I loop. For int I is 0. I is smaller than the count of my geometry, I++. In this case, we need to make sure that the this list is same as the system's all agents list. It has to be matching. So we are going to say circle agent CA is C system dot all agents number I. And then game object current geo is, just say geo, whatever, is a all prefabs I. So this geometry will take the transformation position from CA's center. Does that make sense? And then you have to call this in the update after you update the system. Now, if I run it, what should happen? All the spheres should move towards X direction, correct? Yay. Let me just add one more thing. So when you run this and you create something as a geometry, I'm gonna pause it. Okay. You see that they are created directly inside the hierarchy, right? It becomes a really long list. So I want to just prevent that. You can do that by when you're instantiating it, you can actually give assign a parent of this object at the end of this. So in the instantiation, after the rotation, please add this, which is this object, which is the circle packet, which is the empty object. I'm gonna set this one as parent of all these agents. So I don't have to have like really long dirty list. So say this transform, Control S. And now when you play, all the agents will be child under the circle packing. So you see now you have this triangle. So drop down menu, you will see access all these agents, but you don't have to mess around with this list. So that's a easy fix. Okay, everybody got it from until here? All right, one more thing I wanna do is I want do you remember that we set it up this area range and radius range, right? I want this to be a global variable. So I can actually change it, for example, in the inspector window. How do we do that? So what I'm gonna do here is that I'm going to make this range, area range and radius as a global variable instead of the local one. So I'm going to Control X and put it here and make it public. So this is a default number, but actually it doesn't, it's okay. And then you go outside, circle packing. And then in the start, before we create the system, what we are going to do is we are going to make a float. Sorry, sorry. In the global variable, because we want this to be accessible from global. So public float, let me just go back and copy this. Okay, range, area, range, radius. Okay, so float, range, area, public, float, range, radius. I still want to give a initial value. So maybe I'm gonna set 5 and 10. And if you save this and go to Unity, you should be able to see these two numbers in the inspector. All right, that's great. So these radiuses are only affecting in the beginning, but we still wanna have it access. That's fine, right? So how do we pass this number to the system? Capital? That's fine. Yeah, it can be same, but I just don't want to mix. I didn't want to mix, but you can use same name. Good question. Yeah. So range area, Control C. And then what do we do is after we created this circle system, we can say C system dot, it has range area, right? So I'm going to pass my range area to the circle system. But actually, yeah. Dot range radius. So you can actually pass this pass a information from parent to the next class in this manner. Does that make sense? But there is one problem in this structure. What do you think that problem is? Can I ask? The order of this calculation is wrong because the radiuses and the area is used in the system when it's created, but we are assigning the new value after it, right? So basically, here, what if I set this to 0 as a default here? So I called these lines first, right? That's why I'm using 0 and 0 for area. And then after I created all of them, I assigned the number for the area and radius. That's wrong, right? So that's why we should pass this information when it's created, not after it's created. But you cannot do this. You cannot do this because now there's no system created, right? That's why you need to use this bracket. We are going to pass range area and range radius through this brackets constructor, and then go back to our system and we can amend our constructor and being able to bring a float called range area, float called range radius. And we don't declare this here at all. Do you see the difference? And the relationship is the values passing between different classes. That's really cool. I see some nodding. That's cool. How are you guys? Good, following? Well, okay. That's really awesome, guys. All right, so we created the public air and range. So let's actually go here. And you wanna know that whenever you, even if you have set this as a default, this is priority, this value is priority. So if you set this value while play is not on, when the play is off, it's going to keep this value for next calculation as well. So it's not gonna go back to the default unless you make changes to your script. Okay, now let's see if it really affected. So I'm gonna change this to 5 to see if I really changed it. So it's now the range of the area is 5. And now I can also change the circle radius. It's going to range from 0.1 to 10. Okay, so that's great, but now you don't see the radius. It's because we didn't use the radius as number to change the radius of the sphere, right? So we are going to do that. So come to our setup geometry, and then we are going to both change the radius. We only need to change the radius once in setup because the radius doesn't change, right? So we are going to come here after we created the new geometry. We are going to use transform.local scale. Local scale needs a vector. So new vector 3. And I'm going to use CA's radius. CA dot radius, CA dot radius, CA dot radius. I think we should the scale is dimension, so we should use times 2. Because local scale determines the dimension, not radius. Okay, now let's go back and see. Okay, let's change the radius range a little. That's great. Did you get it? Okay, so now we should just update the movement. So let's go back to our circle agent. So I'm going to follow similarly to the voice script. So I'm going to make another function, not dealing with any updates. It's only about calculating. So void compute velocity or compute direction. What did I call it? Velocity. Okay, that's fine. And then here we are going to always have a direction vector, similarly to our voice script, and then this will help us to add up void agent. Okay, so I'm going to make a private vector 3. I'm going to call it local move. Don't worry about the naming. The default start from is from 0. And then I'm going to calculate this and then always add this velocity to the center. Is that okay? And then every time when I create a local move, I calculate it every frame. So I'm going to start from this being a new 0 again, every time in every frame. So local move doesn't, it's recalculated every time. All right, we are going to also get all of our neighbors. So all of our neighbors will be passed through this bracket from the agent's circle system. So let's go back to our circle system. In the update, just copy paste this line. That we are going to loop through all of the agents again, but instead of update, we are going to compute. So basically, we compute and then update. We compute all of them and then update. So when I'm computing, I'm going to pass all of this list to each agent so they can calculate the neighbor relationship. So this is erroring because in agents, it's not receiving anything. So what we are going to do is list of circle agents, all agents. So basically, in this way, on each, do you remember on each green triangle, I'm looking for the blue neighbors. But in this case, I'm not really like comparing radiuses and just creating my local. I'm just looping through all of the neighbors, which is more heavier and slower for computation. Okay, so I'm going to loop through all of them. So say for int I is 0, I is smaller than all agents count, I plus plus. All right. And then the calculation is, if you draw a circle, you have a circle, right? Then you have another circle next to it. And let's say you have another circle next to it. Sorry, let me draw this again. So the calculation is when you have this circle, it only calculates when something is clashing with me. All right. And the calculation is that I have my center and my neighbor's center. I'm going to check the distance first. Say if I check the distance, if the distance is not my radius plus my neighbor's radius, then I need to repel it, right? So I need to, if they're clashing, where should I go? I should go to this direction, correct? Right? And if it's closer to me, I repel more, right? All right, so, and then for this guy, I will have another red vector, right? And eventually you will have multiple vectors, right? And then you eventually, if you had 4 clashes, you add up all of this and divide by 4. That's the calculation. Good? So let's write that. So we are going to compare the distance and do it only if I'm clashing. Okay. So for all the radiuses, I'm going to calculate a distance. The distance is myself and my neighbors. Center minus all agents I center dot magnitude is the length of the vector. And then there's a desired distance, which is my radius plus my neighbor's radius, correct? So distance desired is a radius, my radius, plus all agent by my neighbor's radius. Right, and then I just need to compare if it's smaller than my desired or not. So you check to see if the distance is smaller than the desired distance. I will do some action. Only when this happens, I will calculate my movement. Otherwise, my movement will be 0. I don't need to move. Okay, so this only does repel. It doesn't attract, but you can write it up later. Okay, so I'm going to make a temporal vector. Temp move. So I'm going to calculate each of these, the red, yeah, so center minus agent center. This is generally the vector pointing to myself. And then temp move and normalize it. This means unitizing it. So I just created a unit vector that is pointing to myself. Repel, basically. And then it's going to be stronger when it's shorter. So if it's closer than the distance, this is the desired distance that I want to repel that much. And then I'm going to add this up to this temporal 0 vector. So this is because it's twice long because it's a vector that pointing from my center to the other one. Okay, and then you need to also divide this local move by the count of the vectors that I calculated. So if you have 4 neighbors, you will have to divide this local move by 4, right? So how do you do that? You will need to make an integer called collision count. I'm gonna start from 0. But I know the count should be integer, but because we are going to use this number to divide, use a divider. Divider cannot be integer, it has to be a float. So we are going to make a count, making it into a float. And then whenever I have a distant collision, I will add up 1 every time. You can also write it like this. And then we are going to let agents, we are going to also pass this number to my agent, to my neighbor. So the neighbor is also moving the half. So local move. So local move should be a public vector. Say local move minus my temp move times half. So basically I'm adding to my move and give the half to my neighbor. So let my neighbor, whenever I have a clash, I let my neighbor also to go away. And then all agents, collision count should be also updated. So that's why the collision count needs to be also a public variable. So I'm going to copy this, Control C, float and public. And then I'm going to only delete okay, then collision count plus is 1. So in this way, I calculated 2 vectors. Actually, it's 1 vector, but I'm passing half to my neighbor and half to myself. Okay, so let's see. Oh, one more thing. So here in the center, in the update, we have to divide this by collision count. Okay. All right. Now I'm there. And now I can, let's see. Can change the range. Yeah, that's it. It's really simple.